Figure 613 MethodOverload.java. One of the key capabilities provided by most object-oriented programming languages is the ability to define multiple methods within one class that all have the same name but different parameter lists. This is used frequently with constructors to create what we call overloaded constructors, where each constructor differs from the next by the number and types of its parameters, and similarly the concept of overloaded methods, where each method has the same name but a different parameter list. In this example, we've got overloaded square methods here at lines 14 and 22. The version here at line 14 is a square method that expects to receive an integer, and the version at line 22 is a square method that expects to receive a double. And the way the compiler is able to distinguish between these methods is based on their so-called signatures, which consists of the method name and the parameters inside the method parameter list. In this case, we have a square that expects an integer versus a square that expects a double, so the signatures of these two methods are indeed different. Now, they can differ either by the types of the parameters, if they have the same number of parameters. If they have different number of parameters, they'll be considered to be different methods. And if they have the same types and same number of parameters, but the parameter types appear in a different order, those would also be considered as overloaded methods. If there's any point at which, based on a function call or a method call, the compiler is unable to figure out which version of a method to call, it will simply generate an error message at compile time. Now, in this program, the compiler is going to decide which version to call based on the argument that we provide in the method call. So, for example, square with the argument 7 here, the number 7 is a whole number, and Java automatically considers all whole number literal values to be integers. So this call here at line 9 is going to result in a call to the square function at line 14, and to prove it, we're going to print when that function gets called so we can see it in the program's output. Similarly, here at line 10, when we call square with the argument 7.5, Java considers all floating point literals to be type double by default. So this method call is actually going to invoke the square method at line 22 that receives a double argument, and to prove it, we will print out that the double version of the method was called. And we're also going to execute this program in the debugger for you so you can see the flow of control as the program executes. Now, before we do that, let's take a look at the main method, where we create an object of our method overload class, and then we invoke the test overloaded methods method on that object, and that's going to get us over to here at line 7, and I'm going to set a breakpoint at line 9 so that we can then step into the methods that are being called. So let's go ahead and run this in the debugger. It'll go ahead and compile the program, and it will show us our various debugging windows down here. We have our local variables, and we have our values as well, and our output rather as well. So now we're going to step into the first square call, and as we do that, watch what happens. We're going to go from line 9 down into the square method that receives an integer argument, and get ready to print out that we called the version that receives an integer argument. So we do that print statement, and you can see down here that we called the version with the int argument that receives 7. We're going to step again to return the square, and we're going to step one more time to show you that the square of 7 is 49. Now we're about to execute the version of the call that receives a floating point number. So as we say step into, you can see that it jumped immediately into the square method that receives a double, and now we print out that we invoked that square method that receives a double. And if we step over once again, we go back to the caller, and stepping over once again prints out down here that we have the square of the double 7.5, which is 56.25. And finally, as we step again, we go back to main, and as we step again, the program terminates. So you can see here that the compiler was clearly able to distinguish between these two method calls and determine, based on their argument types, which version of the method should be called.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.